this is what I want to draw today. This has to be one of my favorite algorithms because the result to effort on it is crazy. I think this is such a cool picture, and it's only about 100 lines of code to draw this. And the idea is really simple behind it. So the idea is this, that we want children, the pixels below the ones above them, to basically be an average of their parents. It's a really simple idea. So this pixel would be the average of these 3 pixels, plus a little bit of random variation to make things interesting. So let's get into it. I'm going to start from this draw function that we wrote in episode 1. And let's go ahead and write some boilerplate. Because we're going to be manipulating pixels a lot in this, it's going to be helpful to have a pixel class. And this pixel class just stores the RGB values for the pixel. Our draw function can't directly draw a pixel. It expects an array of strings. So I'm going to add a toString on this. And we can just call this and then pass in the resulting string to the draw function. Okay, now to populate the first row of pixels in the picture, we're going to need to be able to create random pixels. So let's make another helper for that. Straightforward, just random values for RGB and create a pixel from it. All right, so let's construct that first row now. We have this return of an array of pixels. Make an array of pixels, go through all the columns, and get a random pixel. Okay, let's make sure this is working by trying to produce a picture that has just the first row. So get an array that just has that first row, take all the pixels in it, and get their string representation so that we can pass this thing on to the draw function. Let's see if this works. Sweet. So we got that first row, 10 random pixels. Now let's get into the interesting part where we want to make subsequent rows be based on the row above them. So the first helper that we're going to want to write for that is a helper that, given the previous row and the index of the child in the next row, get the parent pixels above it. So again, the inputs would be the previous row. The output is going to be an array of pixels because you're going to have multiple parents. We need to know where the child is in the next row. And then to make this generic, I am going to want this parent distance variable. And what this is going to do is determine how many parents there are. So of course, the pixel directly above you is going to be one of your parents. But then we're also going to want some number of pixels to the left and the right. So a parent distance of 1 means the pixel above you is a parent, but also means the pixel 1 to the left and 1 to the right is your parent. If the parent distance were 2, we go 2 to the left and 2 to the right. And that's just a variable we can tweak to get different looking pictures. Okay, let's actually implement this thing now. Parents will be an array. Let's go ahead and see what it has in mind, and then we can try to interpret what this writes. I don't actually like the direction it's going. I want to iterate through Yes, I like this better. This looks good. So what this is doing is generate the offset. So this parent would have an offset of 0, this one would have -1, this one would have +1. So the parent index is going to be where the child is plus that offset. So again, an offset of -1 would be this parent, an offset of 0 would be this parent, an offset of 1 would be this parent. And then we got to do a quick check to make sure that that parent actually exists. Like, let's say we're computing the parents for this child. The -1 offset is off the screen. There's not a parent over there, so we can't include that as a parent. The parents would just be this pixel and this pixel. And the same for the right side of the screen. That's all we're doing there. Awesome. So that should get the parents. The next helper we're going to need is a way to average the parents. And we can make this a pretty generic helper. Just get the average pixel from an array of pixels. Great. So iterate through all of the pixels in the array, total up the different values, figure out how many there are, and then just average them. Now, this is interesting. This is taking the floor because we have to have an integer value for the RGB values. But what this is going to do is it's actually make the average slightly smaller than the true average. And if we do that row by row as we go down the board, then the values are going to get smaller and smaller and smaller, and we're kind of just going to fade to black as we get to the bottom. So we don't want to do this truncation until it's needed. And it's only needed when we actually draw the pixel on the screen. So I'm going to take this logic and lift it up to here, because this is where we actually need it. All right, so now we can get the parent pixels and we can average the parent pixels. So we're ready to generate a row. Start here. I don't really need this stuff. So we just need the previous row and we're going to generate the next row from that. I don't know why it keeps wanting to put that in there, but I'll remove that in a second. All right, this is pretty much right. Let's go ahead and hard code this as a constant so that we can tweak this later. Parent distance of 1 seems like a good place to start. So that's just, you get the 3 pixels above you as your parents. We don't need that input anymore. All right, so what this is going to do is it's going to go pixel by pixel in the new row, get the parents for that pixel, get the average of those parents, and then make that average the child value. And now we just need to loop through all of the rows in the picture, generating the next row from them. So we start by just randomly generating that first row, putting that on the board. And then for the next of the rows, we call that get next row function that we just wrote and then put that on the board. And then same thing, after we get the board, just map it to the string values of the pixels. So this should generate a 50 by 50 board. Let's make this a little smaller, so this will be a 500 by 500 image with that. And each subsequent row should be an average of the parents, with the first row being a random row. Let's see what that looks like. Okay. Pretty interesting. You can kind of see, like, we start off fully random for that first row, and then we just bleed into an average, and by the bottom, this thing is totally smoothed out, which is kind of cool. It's a little boring. This is an interesting picture, but if you want to make this a little more exciting, we don't want to make the children the exact average of their parents. We want to sprinkle in a little bit of randomness too. So let's see what we can do. So let's update this get average pixel. Well, I kind of like that. We want to take the average pixel and sprinkle in some randomness. Let's add add randomness. Add randomness to a pixel. Let's see here. Yeah, so this is pretty good. So we're generating a new pixel, get the RGBs. They're gonna be based on that input pixel, but with some randomness. So this is going to return a random number between -1 and 1, and then we multiply by some amount here. Go ahead and factor that out into something else. Call it max difference. This is how much the pixel can vary from its original value. Yeah, 20 seems reasonable. That's like 10% different. Okay, so now what we want to do is get the average pixel, but add some randomness to it. See what that looks like. Okay, I think that's a lot more exciting. You can kind of see this here, that the picture isn't bleeding into just the average of everything. There's something going on here. The next improvement I want to make is having that first row just be totally random pixels is kind of weird. We almost want to do the same thing where this pixel should kind of be an average of its parents, but there's of course no row above it. So we can make its parents the pixels that come before it. Let's try that and see how that goes. So where are we generating the first row? I'm gonna have to move this above. And this is interesting because the parents aren't coming from the previous row, they're coming from this row itself. And yeah, we kind of want to copy the logic that we have for generating the next row. And we do need to do something special just to get that first pixel, because that one has no parents. So that one is just going to be, yeah, truly random. But the subsequent pixels on that first row will be an average of the ones that come before them. Let's see how this is looking. All right, that's a lot better. You can kind of see that, right? Like if we look at that first row, we don't just have random pixels. They're based on the ones that are coming earlier. I like that. That's pretty good. Let's run some more and see what they look like. Yeah, and so we have a couple things we can play with. We can play with the max difference. Again, this is how much the child pixels are going to differ from their parents. So ratcheting this up is going to make the picture look a lot more chaotic. Ratcheting it down is just going to lead to that blending as we go down the picture. So too high is crazy, too low is boring. There's probably a sweet spot in there, just depending on your aesthetic. I think something like 20 is decent. The other variable we can play with is how many parents a pixel has. So with parent distance of 1, each pixel has at most 3 parents. So you kind of these thin lines here. If we want each row to blend more with the row above it, you could increase this. So this would make each pixel have up to 5 parents. And you can kind of see you don't get those thin lines going down the page anymore. It's a little more uniform. Let's actually make the picture a little bit bigger too. Right now it's just 50 by 50, which is kind of boring. Let's do 800. And let's truly make these things pixels. They just have width and height of 1. Yeah, that's a much better picture. I really like the look of that. And now you can really see those thin lines going down the page. All right, one final thing that you might want to do is you can see that we're not really changing that much as we go down the page. The picture is changing, but it's not moving in a particular direction. If we wanted to slowly fade to black as we go down the page, we can, as we generate each row, kind of shift in that direction. So make the random numbers shift downwards instead of actual random. So I'm gonna add a new constant called damping. And this is just how much we're gonna juice the results to make subsequent rows darker than the rows above them. So I'm basically just going to take the randomness we have here and then subtract a little more off of it. Which again is just going to skew the results downwards, which means darker. See what that looks like. So we should like fade to black as we go down the page. Yeah, and that's what we're seeing. And you can make that more dramatic by ratcheting this up. This will go to black very fast. And making this smaller would make it a more subtle effect. So that's it. We ended up with 124 lines of code, lots of it boilerplate helper functions to generate a picture like this, which I think is a really cool picture. As always, I'm going to link to the code. Go play around with it. Make your own modifications to this. I think this is such a cool algorithm.